then it will stop at the first failure, which makes it just a little easier to debug. Okay, so here I have category has no attribute name. So let's start with the test. All right. So one thing you can do, I think, I'm using iTerm, so I'm not sure if this works with everyone, but I can actually command click from the terminal, and then it takes me to exactly like that line where the error is. So that's pretty nice. Then, this is what triggers everything. This is the test that's causing our error, but you can see that first this test caused build category. So that actually starts up here, where you remember like the drop all tables, pass through the test connection, test cursor. That comes from here, comes from source. So I could look at the source folder to see test connection, test cursor, which probably comes from the DB utilities, I'm guessing. So there it is, test connection, test cursor, right? So this connects to my Foursquare test database as a user and some sort of password there. And then we can go back. Now that we kind of understand this line, then we create a category, we assign it an attribute, we save it, and save it to the database. If you're not quite sure how save works, again, you can just command click, right, and look at it and see that it does an insert into. So like along the way, like it's just important for you to check your understanding, right? That's basically what so much of programming is. Okay, and then when we hit yield, right, it yields back to the test. So now we finally do category find by name. This is after having inserted in an instance of, a category with the name of taco places. So it should find it. Now I'll run the test. And we see this is kind of a weird, right? This is kind of a weird error. It says category has no attribute name. We'll go over here. It's breaking right here, right? That's why we're not even hitting my breakpoint, is I'm doing self.name, and it's saying category has no attribute name. Why would that be? Well, that's because, right, this is the class. If you think about what self is in this point, right, self is the class category, not an instance of category. So whereas like an instance probably might have an attribute of name, right, the class does not. I wanted to... Oh, here's a better example of this. Because if you forget to put in, because a lot of times people will forget to put in the class method attribute, right? Let's do this again. And let's say I do something like self.attributes. Let's do a breakpoint here. Actually, I'll run it and then we'll put in the breakpoint. So now, okay, missing one required argument. Cursor. I wonder why that is. This might be harder for me to debug. So this, I think, is also related to the fact that we only have, that we forgot the class name. Let's think about this. This is find by name, test cursor. Actually, this is a harder one for me to understand the error message too. Self, name, cursor. So do I pass through the name here? Yeah, I do pass through the name, and I pass through the cursor. Let's put a breakpoint here, see if it makes it any easier. So this is now going to be an instance method, right? So I'm not quite sure. Let's put in just like some argument, name here, and let's take a look at what's going on, right? Because it says we're missing an argument. So we'll put in 3, actually. And then I'm going to put a breakpoint right here. And we can see what happens when... Do you guys see the issue? Right, I have an instance method, but I'm calling it as a class method. Okay? So now let's run PyTest. Arg is not defined. Yeah, we'll just put in a string. Okay, so now we finally hit our method. And what I want to see is, what are these... Why? I guess I just won't understand it. Why there are 3? It's requiring 3 arguments to come through. Yeah. let's see. So I have self. Self is, I guess what's happens is self is the first argument, so it's no longer implicit. I guess that's what's happening. Is apparently if I, this is an instance method, but I'm calling it as a class method. In that case, this first argument is no longer implicit the way it normally is, right? So because of that, we're getting an argument mismatch, right? Very, very typically, if you forget this, right, like lots of times I'll see someone, we have the test that says find by name, but then we'll forget to actually set this as a class method. What you'll see is that error message that says find by name is missing one required positional argument cursor. Why is that happening? It's happening because when I call, because this is an instance method and we're calling it as a class method, and when we do that, it's not passing through an implicit argument of self here. I don't know why, but that's just the way Python's working. And the point is when you read this error message to, go back to the test and kind of maybe get a hint, if you can remember, that you'll get this missing one required positional argument error when you have this mismatch between like the find by the class method and the instance method. Again, I don't have a good reason for why that occurs, but part of what I'm trying to go through is like hints for how to read these error messages. Okay, so let's fix it, right? We want to remove the mismatch. And then now, right, this is a class method. Self.attributes would work fine in this case, right? Because this is, self is the class, right? It's not an instance, but it is the class. All right, let's go to the next thing. So now, one other thing to note is like if you're having problems with, how to write the method, just put a breakpoint there, and then you can write the method from there, okay? And you can think of like, what are your inputs? You have the name, you have the cursor, the cursor object, and then what is the output that you want? So it's really going back to square one. So the output, and this might be is something with taco places, something about this category having a name of taco places. So, we probably should have a better understanding about the output by now, but I'm just keeping it vague for now. Okay, and now what you can do is you can start actually just writing it in the console. So whenever this stuff, I know a lot of you can do this one pretty easily, but whenever this gets hard, just put it in the console. So do the category query, comma, and then we can do the name, comma, right? And then we can do cursor.fetch 1, and this will be called my record, and we can look at it, okay? And again, like because you're looking at each step, it's a little easier to avoid the errors, and obviously now you can do build from record and pass through the category. You can do category. You could also probably do self here because self is the class, okay? But you can just literally type the word category, that works too, and then the record. And build from record is not defined, so probably have to do source. Okay, and that creates the category object, right? It just wasn't imported here, but this thing has build from record imported, so you get to access it from the init.py file. Okay, so once you have this working, in fact, I'm gonna try to put it in a broken state. But once you basically have this working, you can just copy and paste your code. All right. So what's my point? My point isn't the code I'm writing. The point is put in a breakpoint and then just literally, start coding it out interactively. And let's return this. We'll return record. And this will lead to an error, but I just want us to see it. Okay, so now we have an error, right? And it's actually pretty clear. It's pretty well identified. It says category dot name, and then tuple object has no attribute name. So you're going to get this stuff a lot, right? Tuple object has no attribute name. If we forget to put the return, we'll get none type has no attribute name. The problem isn't that, the thing I want you to remember, just kind of take a second to realize and to, when you see these errors, to identify is that, right, the problem isn't that none type doesn't have a name attribute. Of course, none doesn't have a name attribute. The problem is that we don't expect to have a none here, right? We don't expect the return value, right? This is getting the return value from the method, assigning it to category, taking that return value and calling name on it. And what it's telling you is that this thing right here is none, when it obviously shouldn't be, right? Same thing if we do this. The problem here is that isn't that a tuple has no attribute name, right? It's tuple's like a list. It's not going to have an attribute name. The problem is that we're getting a return value here. When we call .name on the return value, right, what we're calling it on is a tuple. And what this is kind of telling you is, yeah, I don't expect this to be a tuple, right? We expect this to be an object. So we just put back our source dot build from record category record, and that works fine. Okay, and now we can run it. Category. So now we're on to the next test. Category has no attribute venues. If you weren't sure what's going on, about the tuple thing, so just back to return the record. What's another option you can do? Just put, and this is always a technique, just put a breakpoint right before the error. So the error was occurring on this line. Put a breakpoint here, and then look, right, and then try to reproduce the error, right? So we'll run the test. And now, if I try to reproduce the error, what do? I type category, and then I do category.name. Right, and now it's pretty, I think it's it becomes even more obvious what's going on. Oh, okay, so we shouldn't return a blah, blah. So, in terms of just like techniques, right, there's a couple. One is just, it starts from the test. So read the tests, Two is, identifying the error message. So when it says something like, none type has no attribute, whatever it is, name, venues, right? The problem is that we're returning a none. Right? Same thing if it's tuple. Right? Other things we talked about, and then, just to finish this debugging thing, and then put breakpoints. Place a breakpoint right before the error occurs, and then reproduce the error. When I say reproduce the error, what I mean is reproduce it in your comps, right? Put a breakpoint here, and then just literally right, just take a look, category, here's my category.name. Now at this point we reproduce the error, okay? And then we can try to start to understand what's going on, right? Because things are just more visual for us. So reproduce the error, and then finally we said, when coding this, right, you can put a breakpoint in the method, and then code it from the console until it's working. And then one other thing I'd say is if you're confused about what a method does, let's say I'm confused about what this build from record does, put a breakpoint right before the very end of the method. You can even, if it's returning, in this case, if it's returning source.build from record, you can just call this thing an object, right? But because I don't want to put a breakpoint here, because then I'm missing what this last line does. So instead, you can put a breakpoint here, or reassign this to something, and then return the object, return that last line, and then just put a breakpoint right here. So the benefit is when I hit my breakpoint, I want to be able to look at understand every line of code. So how will that work? We'll do it with this build from record one. Okay, so here we are in object, right? If you're not sure, again, you can just command click. It will take me right here. And now you just want to understand what every line of code is, beginning with the inputs, right? So what's class? Class is my category class. What's the record? Record is the tuple. Then what's happening, right? So you can break down this line just by reproducing it, or we can look at the result, because I think of a lot of, we've seen this a lot of times, right? This returns a dictionary. So just go step by step by step, right? Like, there's always a way, if you lean on these kind of techniques, there's always a way for you to basically get the code to tell you what's happening. And that way you don't have to think, right? Like you don't have to guess. The code will tell you. Like you just use the debugger to tell you. And the reason why I'm going through this is, like, I know that a lot of this is fairly easy for you. We've seen this before, but you're going to be working with large code bases where you have no idea what's going on. And you don't want that to be the first time that you're, like, developing these habits. So, like I'd say, these are all types of things that try to do this today, right? Like practice doing this often today when you're going through this. So place a breakpoint at the end of a method before the last line. Then start with the inputs, meaning the arguments. Cool. Let me take a look at the chat. Yeah, there is a completed version of the lab. Of the ORM Relations Lab, I'm not sure. Let me see. I know, I think of this Flask lab there is. Yeah, this one doesn't have one, but the next one, basically like these labs build on each other. So the next one that incorporates Flask, the ones that incorporate Flask have it. And then this one ultimately turns into like an enormous lab, even longer than this. And that one also has a solution. We can go through, do you guys want to go through one of the relational methods? We could do that if you want. But again, let's just do one, and then we'll move on. So the next test we get is category object, right? Has no attribute venues. Here we have this tourspot.venues. I'll just command click on this. It actually didn't take me to the right spot. Okay, tour spot. So it drops all the tables. It saves a bunch of cities, states, zip codes, venues. Here's my tour spot, right? So this is a category. And then here's the venue category, right? So now we finally have this test category venues. So given a category, what are all the venues associated with it? So again, I find this actually kind of hard. So def venues, let's put in self here, and probably need the cursor, it's my guess. And I'm gonna now go back to the test just to see what it says are the inputs. It says just the cursor. You're right, yeah, and self. Okay. So given a category, what are all the venues? And I know, I should have in my mind, basically, a venue has many categories, a category has many venues, and it's this venue category class that's joining it. Yeah, we will have integration tests. Yeah, we will have integration tests as well in Narapati. Yeah. So, okay. So now, what would I do? I'd put a breakpoint here, right? This is hard enough, I think, and just code it out. And now what I do? Cursor.execute, select all from, maybe I would write it out here. I'll just write it out here first. Select all from, what's the return value I want? I want to get back venues. And then what do I want to do? I want to join venue categories, because I know that's my join table, on venues dot id equals venue categories dot venue id. Right? Now I'm loading up these two tables. I know there has to be like a where statement somewhere, because I don't want all of the venues coming back. I only want those where where the category ID matches, right? Where venue categories dot category ID equals %s. So this will be my query. Okay, I'll do cursor dot execute query. And now this right here, this %s, right, this is the category ID. So whose ID are we talking about? Self, the current categories, dot ID, comma, right? Because if you don't put a comma here, it's not a tuple. And now we do cursor dot fetch all. Okay. So now I could have just put the breakpoint here. I'll just put it at the end of this. And the reason why I didn't code it out in here, by the way, is just because it's multi-lines, which makes it then a little hard. All right, and let's see. So let's look at what my records are. So these are the venues. It seems a little long. I think what I'm doing wrong is I don't want all the columns from here. We'll really see that if you do let's just look at one of these. Right, this has 11 columns that we're returning. And like if you remember SQL, that's happening because we're returning all of the columns across the tables I'm joining. So you don't need that. We just need select venues.star, only the venue columns. Right? So if we do this instead, let's just rerun it. And this is a nice thing about tests, right? You can see how quickly I can rerun this. Just rerun it, make a change, rerun it. Now we'll look at the records, square bracket 0. Let's see the length of it. Okay, now it's only 8. And let's go to venues, see if that makes sense. Yeah, 1, 2, 3, 4, 5, 6, 7. I might be off by 1. Yeah, it seems like I'm off by 1. Maybe I'm missing something in venue. I could take a look. But anyway, what would I do from here? Oh, this is my venue ID. See, I have an ID, a venue ID. Let's just take a look again. ID, Foursquare ID, name, price, rating, likes, URL. Oh, and a date time column. I don't know why that's there. Let's just like inserted that. All right, so now there's an alignment. Right, I was missing. It seems like I was missing one column, like a date time column. And then what I can do is, all right, so it's category for each is basically go back through here. So for record and records, call source.build from record. What do I want to get back here? A venue object. So source.venue, and then pass through the record. And these are my venues. And we can put a breakpoint here if we want. And I'm not sure if this will align with the test, but it looks hopefully pretty good. Right, so here's my venue objects. There's 2 of them. And if you just look at one of them, this is Los Tacos Al Pastor, or whatever, is apparently, if I look at what self is the category, right? It's category.venues. So I'm asking the question, what are all the venues associated with this category? And if you look at self.name, this is tourist spot. So this is my Los Tacos Al Pastor. If I look at the second one, it's Grimaldi's. And then if you go to here, you can see this is where the link is happening. where I'm right is through the venue categories. Here I'm saying this is a tourist spot, Grimaldi's, and I'm saying whatever this guy is, venue ID, Los Tacos, right? That's also a tourist spot. All right. So it makes sense now that, right, if I look at the names, actually this probably will pass. Right? If I look at the names, those are the two I get back. Oh, and it breaks. Oh, none type is not iterable. That would be why, right? Because it's back to our old friend. We're trying to iterate through this. Or we're trying to iterate, through this. This is coming from here. I must not be returning anything for my method. Just go back, right? And that's what's going on. Okay. And then run it again. Okay, and it passes. Okay, cool. All right, I'm going to send out this stuff. Maybe put it in a little reading ultimately. But these are the steps you have. Try to use these steps, right? Like that's a goal, is to use these steps. Again, it's not because, like I had to, like when I had a thing is this question about the request response cycle. Right, so this is a very typical question, especially in like back-end engineering. Is just, okay, someone goes to a URL, what happens? So in doing this, oftentimes you may want to draw it out, like let me try doing that. Right, and this is the first thing is like the client. All right, so the client makes the request. The client can be different things. It could be your browser, right? When you like go to ESPN.com or whatever in the browser is the client. If you do something like import requests.get, right? Some URL, foursquare.com/venues, right? This is the client. Like we might even call it client. I think we did, we call it, yeah, this is fine to even call it client, right? And then you can do client dot response or something like that, or client.json, if it gets back JSON, equals the response. So, the client is whatever's making the request. Basically, that's the definition. It could be your terminal, right? As some of you might have seen, you can make like a curl request. But it could be like the browser, when you visit a URL. It could be, Python itself or the code that makes the request to an API. So then what happens? So the next thing is it kind of like goes through the wires of the internet until it hits the computer that normally hosted on Amazon or Google, right? But it hits that the server. You can call like the computer that hosts the API, the server. And then the main thing is in the server, in your API, it hits the controller, right? So with the controller, you can say something like Flask or the API will look through the routes until it finds a match, right? It finds the route that matches the client's request. Okay, meaning, we have a route called /venues. Then from there, so we'll say finds the route, goes to the controller, and then from there finds the route, the matching route. And then from there, the next step is, I was looking actually at the name of those functions, of these, the functions that we're decorating here, if it's like venues. These apparently in Flask, they're called route functions. You call them route functions or view functions. Either one works, but I've been calling them route functions. It finds the matching route and then calls the appropriate, the route function. Okay. And then from there, what you can say, what typically happens, the route function performs the steps to generate a response to the client's request. Typically, This may involve querying the database directly or through a model or through like an ORM/model. Okay. So, from here, this is where we actually, the key thing is then we'll do something like find all, right, venue, and return the venue. Finally, the route function sends back a response. Right? The response, and this, I don't think we spent a ton of time talking about that, but the response actually has 3 components to it, and this is in all applications. So it comes back as like a list, okay? And that the 3 components are the status code, meaning some of you have seen 200 or 404. The body. So the body is like the JSON would be the body, right? The list of venues. Name or whatever, is Los Esgrimales. So this would be the body. So this can just come back as a list of dictionaries. It can come back as HTML, right? That can be the response. And the format, and I think it's the third one is the format type, the response type. So by that I mean HTML or JSON. So it will literally just be some text that says HTML, or it will be some text that says JSON. Okay. So when you from the client's perspective, the client just makes a request, and then it gets back this response that says, remember, like in Python, we can do like response.status code. That's because, the API is sending back the status code. You can do response.json, right, which is giving you back the body. You probably can do something like response.format type or whatever. But this is the response that's sent back. What we code, like Python gives you this for free. It sends a 404 when there's no matching route. It sends a 200 when everything works fine. And then it also sends back, it's able to figure out whether or not you're sending back JSON or text. So it will generate these components for you. But technically, right, this is what's getting sent back to the client. So you can just think of okay, the client makes a request, it goes to like the server, right, or the computer that hosts our API. Then from there, it goes to the controller where Flask finds the matching route. If we find the matching route, Flask executes the route function. The route function generates the response, typically by querying like a database or the model, which queries the database. That is used to generate the body of the response. The response is sent back, consisting of the status code, the body, and the content type, all right, to the client. So that's why it's like request response cycle, because this is then sent back to the client, right? And that's the end of it. So this is something, you can review this. So much of kind of what we're talking about here is contained in the lines of the controller, right? If you look at a typical controller, you can kind of just see it. I guess I didn't write this one out, but right, we find the matching route. Then what happened next? We query the database, and then we send return. Right, we have to write that return statement, and that's sending back the response. Okay. The controller, right? It's just describe the controller. The controller is that, I think of it. We just saw it, right? It handles the requests and sends back the responses. Like that's its main job. So I guess I probably should start with that, but I said controller contains the various routes our API can respond to, as well as the route functions, right, to process it. A controller is concerned with receiving and processing the requests and serving the response. So you can, this is probably the main line. Processing or handling, you could say, the requests, and then serving it, that's the word you'll use, serving the response. We even have access. So for me, I'm like hammering this home by saying like, you even have access to this request object, right? Remember, in Flask, you can say something like, I don't know if I have my Flask app here, but you can say something like, from Flask, import Flask, comma, request. And then when you are in a app equals Flask init, when you're in an actual route function like venues, right? You can look at this request and call it request.params. This object has like information. Maybe we can just show you it for a second. App.run debug equals true. Let's put a breakpoint here. Okay. Init. Why did I do that? Name. And now, right, we're here. We can make a request. I probably need a route /venues. Right now we're in our breakpoint. Right, I hit the /venues. Here we're in our breakpoint. Right, here's the request object. Right, this is what I mean when I say it has information about the request, because you can see here's the URL we requested. We requested a get. Right, it's of type get as opposed to a post. Remember, get is just to retrieve information. Post is to change data in the database. Like if you fill out a form, right, you create a new user that changes by inserting in a new user, creating a Facebook post, right, that creates a new post, like some new record in the database. And you can look at this thing, right, and you can see all the different stuff. Like it knows, the browser that I'm calling this from a Mac, right? It has information. This is why I'm kind of going through this. This may not seem like a lot, or like your controller may seem pretty slim, but just by having access to the request, you have all this information about a request. So this is enough for one given file to do, like handle requests, right? And that's why we try to keep these things just to doing that. And then sending back the response, like the response also, even though it seems slim, has the status code, the response type, HTML, right? So this is a lot of information to have. So, that's the main thing. A controller concerned with processing the request, meaning this whole mess, right? And then serving back the response. Okay. For the model, I say, the model is the data layer of the application, right? Like that's typically true. Some people even have like a separate something even below the model that directly calls the database. But I think most people will accept this. The model is the data layer of the application. It's close to the database, and because of this, we query the database directly from the model layer. Another way of putting that, the reason why I say that is, in the future, like you can do this, right? Cursor.execute. We have the connection, and then cursor.execute. Select all from venues, but remember, we can probably call this from the model layer, meaning you can do like find all, from ORM, import find all. And right, this is our like model layer. And then you can just do find all, and that should return to you all the venues. Same thing if you have a specific venue, what you could do is /ID, and then maybe we have a function called like find one, or maybe we have venue.find by, there we go, like Foursquare ID, right? And then we just pass through this. So in other words, it's kind of nice to not directly query this from the controller, but rather query from the model. Why is that nice? Why would I say that's nice? Because if I lean on this method, then I can use this method in many different spots, you know? Same thing here. We can already see how we can use our find all method. Probably we can find other use cases for calling this. So we're not repeating the same code. We're just relying on this method that we're going to be using, all over the place, probably in our code base. And we're not directly writing the SQL. Right, and it may seem simple, but as these get more complex, right, it's better to just not rewrite our same code, and that leads to us having to debug multiple things. Here we just use one method, keep our code base smaller, all that stuff. Okay, so this is what I mean when I say careful only to query the database from the model layer. Query the database directly from the model layer. So this is technically querying the database, but is using the find all method to write the SQL. This is using the find by Foursquare ID method, right, where the SQL is written. And then I say, if we are following the query command principle, only query the database from the model layer and not change the state of the database. That would be more appropriate in the controller, or even better, a service object, right? Like, basically, you just want to avoid the model. In most cases, you want to avoid, inserting in new stuff directly from here. Instead, you can, right, we kind of talked about this with tic-tac-toe, follow like a process more if those changes are made from the controller, or like I said, even better, maybe a service object, right? We saw that in Netflix too, that we use that service object, and that's what oftentimes the service object ties together many different models, right? Like in order to create a user, you maybe have to create the user, maybe you have to create like some sort of account, maybe if it's a workplace user, maybe the user needs a manager, I don't know. But there are like multiple different tables that are changed. So if you do that in the model, this model is only supposed to be about one table. And all of a sudden now you have all this logic related to many different tables. In the service, it's more tied together. It's all about this one process. Anyway, why do we even have a pattern like MVC? This is probably important. Like, just understanding why is going to make your code better. So I say, first, what is it? Model view controller, separation of concerns, separate out code. This is like you'll hear this language a lot in coding, separation of concerns, meaning, the model is about the database layer. The view is about, what you're sending back as the response, like the HTML, right? You're separating out code that concerns with different things. Where there's a different concern, you separate it. Okay, we separate a code pertaining to querying the database, processing requests and responses, and presentation of the response. Why does this do this? Has more reusable code, right? I talked about that with the find all function, right? By not querying the database directly from here, instead writing a find all function, we can reuse this function multiple times. More organized. I gave this example with the, category, right? Like this method, the find or create by name, relies on another method, find by name. But they both are dealing with the category table, and they're both right next to each other. So if you're trying to understand this code, you're like, okay, category calls find by name. Oh, you only have to go up 3 lines to find it. It's in the same file. And instead, when you're debugging something or whatever, now you don't have to have 10 different files open, right? They're all right next to each other. So more organized, reduces dependencies. The separation reduces dependencies of an individual module or function. For example, a specific model only really knows about the database and primarily about a single table. It does not have any information about the request or the response. So, right, like we get to keep this file smaller and, have to worry about less things in this file. When you open it up, it's mainly you care about, right, the categories table. It knows about the columns of categories, but it doesn't have anything about like, the user's request or like the HTML, right? You're only thinking about one thing. You're just thinking about mainly like categories and things related to it, right? And these functions, again, are very related to the categories table, find by name, right? Here's like kind of maybe an exception is like a relations, but even these are closely related tables to category. More readable, right? It's basically it follows your expectations by by doing this, not having all this crazy stuff that's not, if we had the request object in here and all of a sudden we generate HTML in here, it's like this file will quickly feel like a mess. It's like I have to think, my brain has to now think about the database and the HTML and, requests. Like it's too much. So it keeps it more, easy to read by just having code pertaining to one thing. Okay, this actually was probably what people had I'd say, these answers, like look at them, try writing them out. So many of the questions we hear in interviews are not actually, hey, write this LeetCode problem. Like some of them are, but just as many are probably describe this for me, and therefore, right, like being like facile with like the right language will really help and impress people. Okay, let's go back to think about our domain. So this was probably the hardest, like the thing I feel like we need most review on. So I said we have teachers, students, and courses. And I think what's maybe we'll draw this out. What's most to realize is like the relationships. So we have a teacher. A teacher has how many courses? A teacher maybe has many courses. A course has only one teacher typically. If you're thinking about like a college course or something. Let's do that's the relationship. A teacher has many courses, and a course has one teacher. So it would look like this. Teacher has many courses, right? Teacher has many courses. A course has one teacher. And then a teacher has many students, and a student probably has many teachers through courses. Like what's the link, And then let's say, before we even get there, let's think about courses. A course has many students, and a student has many courses. So whenever you have that many, so let's do that. Because this is probably the key thing. A course has many students, a student has many courses. So this is a many-to-many relationship. I think this is probably where I saw people making the biggest mistake. Whenever you have this many-to-many, right? A course has many students, right? There's 30 students in a course. A student has many courses, right? If you go to college, right, you take 4 different courses, or high school, or whatever, right? So this is a many-to-many, meaning you'll need a join table here. And then we have a student has many teachers through the courses. That's fine. So this would be the link. I think we're good. So the key is we'll need and you can call this different thing. I call it seats, like the seats in a class. And this will have like the course ID and the student ID. And now this says, okay, like say course 1 is biology, right? Biology it has, Sam. And then we have the other one. Here's the course, and then we have another student. That's Rachel. And then we have the second course, and that's also Sam. Okay? So here you can see we have our many-to-many relationship satisfied, right? A student like Sam has many courses, and then a course like biology has many students. Okay? Now for this one, a teacher has many courses. Here you don't need a join. For a teacher to have many courses, all you need to do is decide where to put the foreign key, right? So if you put it here, let's try it here. So we have this teacher's class, teacher's table, and you have the ID and the name. If you put a course ID here, once you put a foreign key, you're limiting it. You're saying there's only one of it. So here you're saying, hey, here's Miss Frisch. She only teaches English, or like what was this? This was biology. Okay, Because if you want to add more courses, you're gonna have to do something like this, course ID 2, and you don't know how many courses she teaches. Maybe she teaches 3 of them. But notice if you put it on over here on the course table, right? Then we're actually good. If you have courses, and then you have name and the teacher ID. This is 1, right? This is bio, and this is teacher ID 1, and now we have this is course ID 2. This is advanced bio, and you can see the teacher ID is also 1. So you can have, right? So we're limiting courses. We're saying a course has only 1 teacher. Maybe we don't want to do that. It's possible you say, hey, this can be co-taught, whatever. But here we're saying, teacher. We are getting the teacher has many courses. Yeah, Alan.
So if we have courses in teachers, the column teachers, when we specify a certain row, for example, fresh for 81 fresh, the next column that would have been courses cannot have many courses ID in that section.
You're talking cannot have a course ID.
Like, for example, at the beginning you had ID, name, and courses, but you said that is not correct because then one teacher would be related to just one course.
Oh, you're talking about right here. If I put it
right there.
Course ID.
But why cannot we populate that space with many courses ID? Like course ID 1, 2, 3, 4, 5, and in just that part.
Oh, and this right here?
Yeah, exactly.
Yeah, that's that's very hard to do. Like, it's not hard. Well, one, you will have to use like a built-in. You'll have to use a Postgres method called like read JSON or read nested. Right, this is nested data. In one column, you have 4 different things. This is harder to do for a data. This is more time-consuming for a database as well, right? Because why? Now think about it. A database has thousands of rows in it. Now for each row, they have to go through all these records before we're done, then go to the next one, then go to the next one. So this isn't normal, so it's costly to do that. It's also fairly confused. It's not what you, right? It's also not like normalized, right? By normalized, right, this would only contain 1 piece of data here.
All right.
Yeah.
Thank you.
Exactly. So Miles was asking that. Right. So this isn't third normal form. Okay. So you can kind of see, so just to review, right? I think the key thing is like you have to get down your relationships, meaning first identify what is this? Has 1, has many. Teacher has many courses. Course has 1 teacher. By the way, it's appropriate for you to ask that question or to say, hey, I'm assuming, a teacher has many, a course only has 1 teacher. You probably would not say, like, I'm assuming a teacher has only 1 course and a course only has 1 teacher because, well, you get this for free. You know what I mean? It's more flexible to say a teacher has many courses than just restricting them to 1. And, like, I don't need, I basically get this for free, meaning I don't have to, as long as I don't have this column right here, right? I just have to add this right here. And I'm already have that flexibility built in that a teacher can have more than 1 course. It's actually more work for me to put like a course ID over here, right? Or So anyway, that's why I would say like you don't like the has 1 relationship. You almost have to do extra work to put that restriction on it. Also, when designing a database, it is you want to be careful to think about like, is it possible in the future, that we'll have a course that has more than 1 teacher? Even one example of that, or might lead you, or it might lead you to at least think about saying, okay, well then maybe this should be a many-to-many relationship. If you have co-teachers of a single course. Why? Because otherwise, what are you going to think about all the work you're going to have to do? You're going to have to take all the data and migrate it into this table. That is work. And then all the methods related to it at the model layer, you're going to have to move them around and then change all the tests. It's a lot of work to change a column in a database. Okay? So that's why you not only are thinking about, you're asking tough questions, detailed questions of the, project manager, the product manager, like, okay, is this, are you sure? Like, a teacher can, a course can't have many teachers. Do you have any examples of that? Even one example, you're not going to be able to represent it. So putting those restrictions, you just want to be careful about it. All right, and then the next thing is, once you have down these relationships, performing the query. All right. So here I actually left this for you to do. So do you want to try this one now? I'll give you like 3 minutes. Right, this is in Slack, by the way. So the model is, we have ID name, student's name. The join is between a course and a student is the seats. And then we have this courses. The courses is how we have a course has one teacher, a teacher has many courses. And then what are we asking for? We're asking for all of a teacher's courses. So basically, think about writing out the select statement. And then if you finish this one, you can get started on the next one, obviously. But I think this is pretty good. Alright, so let's go through this. So for me, the first step for me is I like to think about what class I'm in. So I'm in a teacher class, right? I'm asking for a teacher's courses. So the return value is going to be courses. So I normally do something like this, select all from courses just to get started. And then it's like, which courses do I want? I want the teacher's courses. And then the question is, okay, well, if so it's going to be like where, some information about the teacher ID. Right, because this will limit me to the teacher's courses. If I do where teacher ID, equals %s, and then here I'm passing through that teacher's ID, right? So the question now for me is like, do I need to join another table to get to teacher ID? And you actually don't, I think, right? Because a course has a teacher directly there. So actually you're good just by writing this. And you can do, if you wanted to, you could do courses.star, but you don't need to do that either because this just says just limit it to this one table. I want the columns returned, just limit it to here, but we're only have one table, so we're good. So this is fine if you want to do that. And then again, remember, this is give me all the courses, but only those where the teacher is this specific teacher. Cool. This one's harder. How do we get to the students from a teacher? So again, I would start here again, select all from students. So first get to the students, but which students do you want? You want those where somehow related to the teacher. I don't know what it's going to be exactly, but like teacher ID equals, some sort of self.id again. But how do we actually get to this teacher ID column? So we have a student. If we go back to our diagram, we have a student. A student has many courses through the seats table, right? Because I'm basically looking for that teacher column. So there's no teacher column here on the seats table. There is one. A course has only one teacher. So actually we're good once we get to this table, right? Because a course has a teacher ID. And then we can say where the teacher ID is self.id once I get to this table. I think we're good. Okay, so we have to join this table and this table. So it would be select all from students, join seats on, and now I have to say how they link up. So it has to be my students .id equals seats dot student ID. And now I need to, so this gets me to my seats table, and now I need to get to my courses table, right? Join courses on, how do these link up? Oh, do I not get, I need to, yeah, I can get to it. I can do courses.id equals seats.course ID, right? Because the seats also has the course ID. And now I have to join courses, right? Because my whole goal is to get to this teacher column. Join courses on courses.id equals seats.course. Oh no, did I already join courses? Sorry about that. So now I have courses loaded where courses.teacherID equals %s. And then I pass through that teacher's ID. And here I do need to, if I just do select star, that's going to be back like a crazy amount of columns. So I just want to say, just give me the students column and then build from record each student. So just to go through this again, loading up the students table, then I'm joining the seats, right? Because that's how I get to courses, is students ID joins seats.student ID. So that allows me to load up the seats table. And then this seats table has the courses. So that allows me to join courses on courses ID seats.course ID. And now this courses table has the teacher. So now I can say where courses.teacherID is this specific ID. That will give me back all the students from this teacher's course. Okay. All right. So that's everything. Like I said, I would take a look at this, like put this on your own words. Feel like you feel comfortable with this. Yeah, Conwell.
Yeah, just a quick question regarding the asterisk over here. If we didn't qualify it with students and just set select star, in most of the databases I have worked on, that actually gives ambiguity error that there are common columns found in these tables. But I've seen that
Right.
Postgres doesn't do that. So if in case it doesn't do that, how would we differentiate between the tables which we got this specific column from?
Yeah, you would give so the question is, like every table has an ID. So we're joining multiple tables, like students ID, teachers ID, courses ID. So how do you differentiate? It would be with the table prefix. You could do students.id, comma, students, if you just want to be specific about which column it is, you give the table prefix. Does that make sense?
Yes, but what I mean is in the result which we get. So suppose we had select star from this whole join. In the actual result which we get, will that also contain those prefixes?
No, not with this. No, because it just comes back as a tuple, right? Like it doesn't even have the column names. It will give you just back a tuple with all those attributes.
Yeah.
Yeah.
Okay. Thank you.
Mm-hmm. Yeah, Narapati.
Yeah, Jeff. So if we say student has many teachers and teacher also have many student, which is a many relationship, why wouldn't we create like a middle table that that connect student and the teacher?
Yeah, let's think about it. It's a good question. So, okay, so here's kind of our diagram. A student has many teachers. A student has many teachers. Teacher has many students. If you create the many to many relationship, so let's say we have like teacher students. Well, now, okay, so this is like teacher ID, comma, student ID. Let's make this a little bigger. And then, teacher ID is 1, the student ID is 2, teacher ID is 1, the student ID is 3. Okay. What we already have is we already have this link, through the seats table. Like what makes this teacher-student relationship, whatever, is that we have this student is in this course, and this course is taught by this teacher. So now let's say we want to delete it. We want to, we remove this student from the course. Well, I remove the student from the course. My work should be done. Like the way I have it modeled without this, now I've removed the teacher-student, right? Like I've removed the student from the course, my query automatically works. It's no longer going to return this as one of the students. But if I also have this table, I have to not only remove the student from the course, but I also have to remove I have to change this as well. So you want to try to avoid that, right? Like we're representing the same information. If you do it this way, you're representing the same information in 2 different spots. And so that's just very prone to bugs because you can just forget. It's like, why do I need this? You'll forget to delete it in both places. Or these can get out of sync, right? I can now, right, that you delete it here, but you forget to delete it here. And now the question is, well, which one is right? So that's why people talk about with databases, like you want everything just one single source of truth, right? That's another way of confirming you have third normal form. Here you have 2 pieces, 2 tables answering the same, that help you answer the same question, right? Because here I have my student-teacher relationship is through this, but then also through this. So there's 2 different sources, 2 different tables that can answer the same question about teachers and students. So you want to try to avoid that. Cool. By the way, we really had to worry about this in one of the applications I worked with because it was all about like social workers managing, foster children. So, and literally, like, we were the database of record for, like, the state of Indiana. So it's like, if a child is in a foster parent's care, right, you can't be out of sync on that. Because it's literally, that is like the legal binding as far as like the state's concerned, defining the relationship. So it has to be, you really have to be careful about some of this stuff. Same thing like healthcare records, things like that. You don't want those things to get out of sync, and you want to have all these quality controls, but then having them in 2 different spots is, very prone to errors. All right. So anyway, that's why. So yes, you would remove you would not have this one. No. Right? This does it for us. Cool. All right. Cool. So yeah, let me open up the breakout rooms and then, I'd say review this. You can, if you want to keep going with your lab, fine, but then review it at some point.